Hey everybody, here I am making a quick video on geometric probability. Probability, as you all know, is a ratio of things you're interested in over a total number of things. In this case, it's going to be the areas of shapes we've got. This very first problem is a target that is a rectangle that's 30 by 60 centimeters, and that bullseye is a square that's 10 centimeters long on each side. So if we have a drawing here, it's going to look something like this. There's our total area, 60 by 30. There's our bullseye. The solution then is going to be something like this, where a target is that 30 by 60, total area of 1800. That bullseye that will be in the numerator is just 10 by 10, that's 100. 100 over 1800, very simply 1/18, or about 5.5%. This next one is a little bit more traditional type of target. Imagine archery or something. We've got an outer circle that is a radius of 30, and an inner bullseye has a diameter of just 6 centimeters, so pretty small. So the solution then is going to be that same type of ratio. The larger target is going to have an area that's pi r squared. 30 squared is 900 times pi. We just keep the symbol in there. I can multiply it by 3.14 if I want, but because I have a ratio, those pi's will just cancel and I'll not have to worry about them. The bullseye has a diameter of 6. Oh my goodness, a little typo here. This then, if the diameter is 6, this is a ratio of 3. When you that as a radius of 3, and when you square it, then you get 9, sorry. And so this becomes a ratio then of 9 pi over 900, which is then 1 over 100. The pi's cancel, the 9's cancel, 100, which will then give you a radius of 0.01 and a percentage of exactly 1%, okay? So then down to the next one. Going to go down here. There we go. Keep going. Yep. Now we've got this Goliath the robot, funny shaped mask. You've got a bullseye that's right between the eyes, out of like the biblical Goliath, and then you can get him in either eye. That's just as good. So your whole target is that 20 by 30 rectangle. That's 600 square centimeters. The bullseyes are the two circles, each like the last with a radius of 3 centimeters, giving you an area of 9, but there are 2 eyes, so you multiply by 2 for a total of the eyes area being 18 pi. Don't forget the rectangle that's 8 by 7 between the eyes up there and the forehead. That gives you another 56. When you add those two, they're close to being equal. You get 512.549. That's your bullseye area divided by your total area, gives you about 18.8%. Okay, next one now, you have to imagine that you and a cousin are out shopping online. I guess you're not out, you're in, as we are in shopping online for a major gift for your grandparents, milestone anniversary. You share a gift card that's got a total of $75. Your older cousin is a bit bossy and thinks that he should be allowed to spend up to $60, but promises to do it randomly between 0 and 60. And you can have what's left over, but you're given a budget between 0 and 30. And you can also spend randomly, so you might each be low, you might each be high. We want to know, what is the probability that you go over your $75 limit? Okay, well, think about this in terms of geometry by making your cousin's spending be the x-axis and your spending is the y-axis. So there's your cousin who can spend anywhere along this 60, and you can spend anywhere along that 30 unit axis. So if there are random points chosen, you could end up anywhere in this zone here that would be bad because you've overspent. How do I find where those points are? Imagine your cousin has spent all of his $60 and you can spend up to that boundary of 75. That would give you spending in the y direction of up to 15. Make a point there. Then think conversely, if you spent all 30 and called your cousin, they could go out to 45 and not spend more than 75, and you make a dot there. Then you just simply connect the two dots, shade in that area, and ask what's the ratio of those areas. Well, the area of a triangle is 1/2 base, which is one side perpendicular to another side, in this case of an isosceles right triangle. And then when you find the product for those two, multiply 15 times 15, just cut it in half. It's like saying, hey, a square that's 15 on a side is cut diagonally in half. You could also make a grid out of this, and you'd see that it's got 8 squares, and that final square is cut in half. So half of 1/8 is 1/16, or you can just simply use the numbers and you get that 6.25%. Okay? Hope that helps.